Hello everyone, welcome to MemoNeet. I am Aprajita, your chemistry SME. I welcome you to today's session. So as you all have given PPT 6, I hope it went well. You have revised a lot of chapters till now. So today we are going to start with a new chapter, that is your chemical thermodynamics. Okay, so this is the chapter which is present in your class 11th syllabus and it is going to come for PPT 7. So for today, we are going to revise this chapter, that is chemical thermodynamics. But before that, I want to talk to you. So tell me, how's your preparation going on? See, I can't see any comments, any likes on my video. I hope you people are enjoying the lectures and you are understanding what we are teaching you, right? So please do comment like what else you want from us, what else you want us to teach. Okay, and if in case there are any doubts, you can ask us on the comment section, and you can also join the Telegram channel. Okay, there we are providing you with all the guidance and support. Daily targets are there, daily quizzes happen in the Telegram channel, so the link to join those Telegram channels are in the description. You can join that. Okay, and students, we are also launching a droppers batch. Okay, MemoNeet is launching a droppers batch. So this is specifically designed for the dropper students, okay, which includes the 36 tests. Okay, the BPTs that we are having, total 36 tests are there. Yes, students, it also includes our NTA PYQ book. Okay, and let me give you a very good information that our NTA PYQ book is out now. So if in case you have not ordered your set of NTA PYQ book, all the 3 books will be provided to you in the droppers batch. Okay, all the tests will be there, so you can attempt the daily test series. Okay, moreover, you will get the elite plan, the BRPs, means whatever features are there on our app, all will be included in your droppers batch. Okay, so all these things you will find in our batch. So in case you want to join that, you can join that. Okay, moreover, students, you are going to get all the lectures. Okay, the lectures from basic to advanced, all the lectures would be there, and there will be a WhatsApp support group where 24/7 SMEs would be available to solve your doubts. Okay, so make sure those who are droppers, they can take this batch and they can make full use of it. Okay, and today we are going to start with thermodynamics. Okay, that is an important chapter. Chemical thermodynamics, an important part of physical chemistry, but an easy chapter also. Okay, basic chapter carries some weightage, some good weightage in your NEET examination. Okay, so that's what we are going to start today. So we will be mainly focusing on the introduction. Means, see, this is what I suppose I am teaching to you for the first time. Means this is the first time we are studying thermodynamics. So we need to understand some terms that are used in thermodynamics. Okay, so those terms I am going to discuss with you. Then we will be mainly focusing on the first law of thermodynamics. Okay, what is the first law of thermodynamics? And then we will be focusing on various types of processes and the enthalpy changes that happen. First law of thermodynamics may I'll be discussing the applications as well. Okay, so all these things we are going to cover in our today's lecture. So the very first thing, if I talk about thermodynamics, firstly we need to understand what it is. Okay, what do I mean by this thermodynamics thing? So you know that in chemistry we study about the chemical energy. So we know that molecules actually store some chemical energy. So that chemical energy can be released as heat during the chemical reactions. Like suppose when a fuel is burning, methane, cooking gas, or any coal is burning in air, so chemical energy will be released as heat. Okay, that chemical energy can also be used to do that mechanical work, like that fuel that we are burning, energy is being released, so that energy is used in the engine to make the engine work, right? So that is converted to mechanical work. Or like in galvanic cell, dry cells, we provide electrical energy. Okay, like the chemical reactions happens inside the cell and that energy is converted to electrical energy. So what I can say here is like chemical energy is converted to heat energy, then it is converted to mechanical energy, and so on. So what happens is that various forms of energy are interrelated with each other. That's what we understand from here. Okay, and this energy can be transformed from one form to another as well. So the study of these energy transformations makes the subject matter of thermodynamics. Means basically in the thermodynamics I am going to study, or we are going to study about the energy changes. All right, we will be studying about the energy changes that happens around us, not just the microscopic systems. Okay, we are like till now we were talking about atoms, molecules, structure of atom, chemical bonding. No, this law of thermodynamics that we are going to study, they will deal with the energy changes of macroscopic systems also, involving large number of molecules rather than microscopic systems. Okay, so we will be mainly talking about the macroscopic system, but one thing that we should know is कि thermodynamics is not related कि how and at what rate these energy transformations are carried out, कि कैसे हो रही है, किस rate पर हो रही है. No, but we will be just studying the initial state, कि energy transformation होने से पहले what was the initial state, and once all the energy changes have been taken place, what is the final state of the system, right? So that is what we are going to study. So these law of thermodynamics, they'll be applicable only when the system is in equilibrium, that you must know, okay, or moves from one equilibrium state to another equilibrium state. Okay, why? Because these macroscopic properties that we have, pressure, temperature, they do not change with time for any system in equilibrium state. Okay, so I hope you might have got an idea what we are going to study in thermodynamics. Now, very basic, I told you there are some thermodynamic terms that I need to study. Now, we are doing some research or we are doing some work, right? We are actually observing something. So we are having two terms in thermodynamics. Let me tell you. One is system and the other one is surroundings. So you must have a knowledge of what is system and what is surrounding. So a system in thermodynamics refer to that part of the universe in which observations are made. Means let's say I am I'm doing a reaction in a beaker and I'm observing that. So that beaker, okay, that beaker is my system. Okay, at that time, that beaker is the system and rest everything apart from that beaker is the surroundings. Okay, means the surroundings include everything other than the system. And this system and surrounding, they together constitute the universe. Alright, so system is actually something which we are working upon. All right, like let's say this is our cylinder in which some gas is being filled. So we are talking about this system here and everything apart from that system is surrounding. So you must know that the system and surroundings, they are separated by something. Okay, that can be imaginary, that can be real also, and that is known as boundary. So system and surrounding, they are separated by a boundary that can be an imaginary boundary or can be a real boundary as well. Okay. So the thing is कि whatever we are studying, so the entire universe that is other than the system, it is not affected by the changing taking place in the system. Means whatever changes are taking place, they will be taking place in the system only. Surroundings में nothing will happen. Okay, so that's why we take the surroundings as that portion of the remaining universe. It can interact with the system, okay, no issues. It can interact with the system, but rest nothing happens in the surroundings. So our matter of study will be the system only. Okay, so that is the thing. Now there are various types of systems that we are going to study in thermodynamics. Okay, so first of all we have an open system. Okay, now in the type of system, I'll be talking about two things, that is mass and heat, or you can say energy. All right. So basically students, what happens is the type of system where both mass and heat transfer can take place. See, I told you now कि obviously surrounding can interact with the system. So what is happening कि if mass is also getting transferred to the surrounding and energy is also getting transferred to the surrounding. Okay, mass also and energy also, or heat you can say. So that is going to be an open system. Let's say if you are taking boiled water, keep it in a mug. Okay, after some time, if you keep it for some time, you will see that boiled water now it is cold, like, or it has come to normal temperature. Okay, so what has happened, and that boiled water might have vaporized also, like vapors bhi bane honge, right? So the vaporization means the water liquid, it is converting to vapor, so that is mass transfer. Okay, and the temperature, from boiled water now it has come to normal temperature, so that is heat transfer. So that's an example of an open system. Okay, now try to understand what is a closed system. So in closed system only heat transfer will take place, only heat. Okay, mass will not. Mass will stay inside the system only. Now how it is possible? Let's say if we are taking a boiled water but you cover it with a lid. After some time you will observe that boiled water has come to normal temperature, matlab heat transfer hua hai, right? But if you like open that lid, you will see water vapors that have been condensed as water droplets on the lid. Means those water vapors that were getting formed, vaporization ho rahi thi, but those water vapors, they could not escape into the surroundings. Try to understand, because I have covered it with the lid. So they cannot escape to the surroundings. So mass transfer has not taken place. Okay. So no mass transfer has taken place, but only energy transfer has taken place. Now, if I talk about isolated system, so isolated means like the one that is isolated. Okay, means it has nothing to do with the surroundings. Means where neither heat nor mass transfer takes place. Like you take that boiled water, keep it in a thermo flask. Okay, so thermo flasks are there, no? So जिसमें ठंडी चीज ठंडी रहती है, गर्म चीज गर्म रहती है, like for a long period of time. So it means that is an example of isolated system, because there the heat transfer will also not take place and mass transfer will also not take place, right? So that is your isolated system. So we should know, when we are studying thermodynamics, we should know the different types of systems that we are having. Okay, now next is thermodynamic properties, very important. So there are actually two type of thermodynamic properties, students. One is intensive properties and the other one are extensive. So IN से याद रखना, IN stands for intensive, IN stands for independent. The properties which are independent of mass of that substance or of like whatever we are studying, if the properties are not depending on the mass, we'll call them as intensive properties. Means their value will remain uniform throughout the system. Let's say boiling point. If I talk about, I have taken a glass of water, I'll like try to boil it. It will boil, let's say under standard conditions at 100 degrees Celsius. Now out of that glass of water, I take a small portion, I boil it. So that boiling point will remain 100 only. Now it is not going to change with the amount. Earlier I have taken 100 ml, now I have taken 10 ml. But the boiling point is going to remain same. Meaning is that it is going to be independent of the mass. And they are non-additive. So we are not going to add them because they are not dependent on the mass. Their value is constant only, right? Temperature. Temperature is also an intensive property. Luster. So these examples I have taken. Now, if I talk about extensive properties, those properties which depend on mass or the amount of substance that we are taking. Okay. So, but the thing is that they are additive, of course, like volume, mass, weight, of course, they depend on mass. And if you take ratio of two extensive properties, it becomes an intensive property. Let's say if I am taking the ratio of mass and volume. These are two extensive properties. So mass and volume becomes density. And density of a substance is an intensive property. See, that's what we want to explain. If you are taking ratio of two extensive properties, it is going to become an intensive property. Okay. So that is the term about the thermodynamic properties. You must know intensive and extensive. So that these were some examples. Now this flow chart you can make in your notebook. Okay. Here I have extensive properties written. Let's say volume, number of moles, mass, free energy gives free energy that we have, entropy. Okay, entropy, enthalpy we will study now. Heat capacity, internal energy. These four terms we are going to study. Okay. Then intensive properties is the molar volume, density, refractive index, surface tension, viscosity, free energy per mole, specific heat, okay, pressure, temperature, boiling point, freezing point, all these things. So this flowchart is very important because you must know what are the intensive and what are the extensive properties, because yes, questions can be asked from this topic in your NEET. Okay, important from NEET point of view, extensive and intensive properties. Okay, so moving on. Now students, another important thing is, let us talk about the state of the system. Now if I talk about system, state means we need to describe the system also, right? Whatever system is being under observation which we are studying, we need to describe it in order to make any useful calculations. So we need to tell about its pressure, let's say volume, we need to tell about its temperature as well as the composition, ki what it is made up of. Okay, so we need to describe that system not only just before the change but after the change also, ki let's say if P1, V1 and T1 were before the change, and after the change pressure to, volume to, temperature to, means these were the values. So we need to describe both of them. All right, so the thing is that we specify the state of the system by state functions. So in thermodynamics we call them as state functions. Okay, so we can describe the state of gas, let's say by quoting its pressure, volume, temperature, number of moles. All right, so these P, V, T values, whatever we are using, they are known as state variables or state functions because their values depend only on the state of the system. So their volume values will not depend on how it is reached. So we have two type of things, state functions and path functions. So those thermodynamic properties, this is important, that depend on the initial and final state of the system. Okay, means let's say if this is the initial state of the system and this is the final state of the system. So I can move like this or I can go like this to B. So that properties, they will be same for both of them. Okay, for both the paths they will be same because those properties do not depend on how that path is reached, means how that state is reached. It will just depend on A and on B. But for example, pressure, volume, temperature, Gibbs free energy, internal energy, entropy, okay, all of these. But path functions are those whose value depend on path, like heat, work, loss of energy due to friction. Means let's say if I'm talking about A and B, so work will be different for this path and it will be different for this path. Means that will be dependent on the path followed. Okay, so these are the two things. Now I need to talk about internal energy. Okay, so internal energy is something that we are going to study, okay, in thermodynamics, very important. So internal energy means the sum of various types of energy that are related with the system. A system can have lot of energies, right? Mechanical, kinetic, thermal, like a lot of things can be there. So the sum of those various types of energy for a system will be known as internal energy. Means I can say कि whatever energy is possessed by the system, that I will talk as internal energy. So in thermodynamics, internal energy is represented as E or capital U. Now how can we change the internal energy of the system? That is the question. I can change the internal energy of the system by doing work. That's what we are going to see. Let's say if we are having some quantity of water in thermos flask and or in an insulated beaker, means I am taking an isolated system. Okay. Now when I say isolated system, I think I have explained it to you clearly ki what is isolated system. Okay. So I have taken a thermos flask and I have taken some water in it. So that thermos flask or that beaker will not allow exchange of heat between the system and surroundings through its boundary. So students, now something very important is coming up. Please star mark it and note it. That whenever there is no, okay, I think I need to write it with other color. So whenever there is no exchange of heat, okay, if there is no exchange of heat between the system and the surroundings, we call that type of system as adiabatic system. Very important thing, please note it. Whenever there is no exchange, means isolated system is an example of adiabatic system because where there is no exchange of heat. Okay, fine. Now if I have this adiabatic system and I want to change the state of this system, so that process I will be doing, that will be known as adiabatic process. So in thermodynamics now we have lot of processes. So if you are changing the state of an adiabatic system, so that process that you will be followed will be known as the adiabatic process. Okay. So please note that adiabatic process is the process where there is no transfer of heat between the system and surrounding. Means जब वो process होगा, in that process also there will be no transfer of heat. Okay, so that will be adiabatic. And the wall separating the system and surrounding is called adiabatic wall. So see, matter is remaining inside only, energy is inside only, Q is 0. Q is actually the heat. Okay. Means there is no heat being exchanged. So that's why we have taken the value of Q as 0. Alright. Okay. So next is, now when I am doing the work, I have explained you what is adiabatic process. Let's do some work. Okay. So I want to change the internal energy of that system. So by some work on it. So initial state was A. Its temperature was TA. Okay. And the internal energy was UA. Now I have done some work. We had taken water in that insulated beaker now. So we have, like, what we are doing is we are rotating it by a set of small paddles. Means I'm churning the water. Means we need to do some kind of work. We are churning the water. So of course energy change hoga, right? So that new state, let's call it as state B. So this was state 1 A and this was state B. Now the new temperature will be TB. And let's say it is found out that TB is greater than TA. So the change in temperature will be called given by delta T. Okay, delta TB minus TA. And the internal energy will be UP. So of course, agar temperature increase ho raha hai, of course internal energy will increase. Okay. So in that case, delta U will be UB minus UA. That is the change in internal energy. Okay. Now let's say we are doing equal amount of work. Earlier 1 kilojoule work was done. Now equal amount of work is being done 1 kilojoule. But the method of doing that work is different. Okay. Let's say if you are going from A to B, like I've just explained you, either you will follow the straight path or you will just like move around, roam around, and then you will reach to B. But the amount of work that is being done by you, that I am saying it's same. Okay. So we are doing equal amount of electrical work now. Earlier we were like rotating the water, we were churning it. It's just an example I am explaining you, okay? Now we are taking an immersion rod and let's say 1 kilojoule of electric work is done on that water. Again temperature change, we will see. So we will find that change in temperature is same. So let's say delta T, again it will be TB minus TA. So various experiments were done in this manner, okay, by J.P. Joule, and it was found out that for a given amount of work done on the system, no matter how it was done, means irrespective of the path, it produced the same change of state as measured by the change in temperature. Matlab, I have done 1 kilojoule of work in both the cases, but the method of doing work was different. Okay, but it was found out that the temperature change was same, right? So it seems appropriate to define a quantity, internal energy, whose value is characteristic of a state of the system. Okay, so that we will be talking as delta U. So delta U is U2, or you can say UB minus UA. Okay, and C students, that will be equal to WAD. Now what is this WAD? It is the adiabatic work that we have done. Means the work done that is being done, it will be equal to the change in internal energy of the system. That's what I want to explain. Okay. The adiabatic work that we have done, it is equal to the difference between the internal energy of the system. Delta U. So now let's go back to what was meant by state and path function. So that internal energy is not dependent on how that work was done, electrical work or mechanical work. It just depends on कि हाँ work हुआ है, work has happened. Means the internal energy just depends on the UB minus UA, means the initial and final state. So it is a state function. Okay. See, this is the basic that I am telling you, because यहाँ पे you need to know the sign conventions also. Alright. अब यहाँ पे the work was done on the system. We churned the water and we like provided electrical work. So that work done on the system will be positive. Okay. So please note that whenever work is done on the system, that is positive. But if the work is done by the system, means if system is doing work, means expansion हो रही है किसी gas की, okay, that we will also study. So work done by the system is negative. Okay. So students, that was one case where we did some work and internal energy of the system changed. Okay, so you must know the sign conventions. Work done on the system positive, work done by the system negative. Okay. Now we can also change the internal energy of the system by transfer of heat from the surroundings or vice versa without expenditure of work. Earlier there was no heat transfer. Now we can transfer heat but will not do any work. सिर्फ heat transfer से ही internal energy will change. Okay. So that exchange of energy, we will, let's say it is Q. Okay. So now this is not adiabatic system. Okay. Now we are taking thermally conducting walls. So these walls are actually thermally conducting. Thermally conducting walls ka matlab that it can allow the passage of heat. They are not adiabatic walls. Okay. So means the system which allows heat transfer through its boundary. So if we take water as temperature TA in a container having thermally conducting wall, let's say copper, and if we put it in a huge heat reservoir at temperature TB, okay, we have like put it in a higher temperature reservoir, so the system will absorb heat. Of course bahar se andar heat absorb hogi. Okay, so we can measure that heat that is absorbed by the system in terms of Q. Okay, so that will be in terms of the temperature changes TB minus TA. Okay, so in this case you will say ki that the internal energy is equal to the heat absorbed or released by the system, whatever it is, when no work is done. Okay, यहाँ पर कोई काम नहीं हो रहा है at constant volume. Now again you must know कि that the Q is positive. Now अब इसका भी sign convention है. Heat transfer Q is positive when heat is transferred from the surrounding to the system. अगर सराउंडिंग से सिस्टम में हीट आ रही है सो Q विल बी पॉजिटिव एंड Q विल बी नेगेटिव व्हेन हीट इज ट्रांसफर्ड फ्रॉम द सिस्टम टू सराउंडिंग, मतलब सिस्टम इज releasing the heat, so that it would be negative. Okay, please note that also, this is important. So now I think you have understood ki how we can change the internal energy of the system by transfer of heat or by doing work. So that takes us to the first law of thermodynamics. So I am now taking a general case. General case means कि जहाँ पर change तो हो रहा है by doing both work and transfer of heat. So in that case the change in internal energy would be Q plus W, means कितना work done हुआ and कितना heat transfer हुआ. Sign convention I have already told you. Okay. So Q and W can depend on how the change is being carried out, right? So it will only depend on initial and final state. As I have already told you, internal energy is a state function and it will be independent of the way the change is carried out. Let's say if no energy, no transfer of energy happens or no work happens. Okay. So it means the delta U will be 0. अगर Q 0 है and W is 0, so obviously delta U is 0, means that there will be no change in internal energy. System will remain as it is. So this delta U is equal to Q plus W is the mathematical equation of first law of thermodynamics. Okay, so what we are saying is कि अगर कोई काम नहीं हो रहा है and no heat is being transferred, means the system is isolated. I told you, no heat transfer, no work done. So the energy of that system will remain constant because internal energy is not changing. So the first law of thermodynamics states energy of an isolated system is constant, or we can call it as law of conservation of energy also. That is, energy can neither be created nor be destroyed. So that is our first law of thermodynamics, and this is the mathematical expression for the first law of thermodynamics. Okay. Now students, we will be seeing the applications of first law of thermodynamics. So we will be studying about work done in various processes, okay, ki how work done is there and what are the expressions of work done in various processes. So here we are just considering the mechanical work as of now. Mechanical work means we are considering the pressure volume work. Okay, so pressure volume work we will be considering for the gases here. Now, here I have a cylinder, okay. Let's say 1 mole of ideal gas is there. Ideal gas is present in this container, which is fitted with a frictionless piston. Means there will be no loss because of friction. So we are considering frictionless piston. This is your piston, okay. All right. So the initial volume of the gas was Vi, okay, and the pressure was P. P was the pressure of the gas inside the piston, okay. Now let's say we are applying some external pressure, means if P external, Ex means external, is greater than P, so what will happen? The piston will move inwards, no? It will move in this direction, see in the diagram. So if it is moving in this direction until the pressure inside and pressure outside becomes equal. So let's say it has moved and the of course the volume will be reduced, right? Compression हो रहा है, so volume will be reduced and Vf is the final volume, okay. Vf is the final volume of the gas. Let's say कि the piston has moved through a distance of L and the area of cross section of piston was A. This I am talking about area of cross section, this one of the piston is A. Okay, so we have to find out the work done. So here, now if I say कि the volume change Vf minus Vi, volume change will be A into L. Area into length भी तो volume होता है, right? So Vf minus Vi will be area into length. Okay. So this is the volume change that I am talking about, and let's say this is delta V. Okay, delta V is the volume change. Now students, if I talk about the formula for pressure, so you know these formulas already. Pressure is equal to force upon area. So if I want to calculate the force with which we are like the force that we are applying to compress the gas, it will be pressure into area, right? And the pressure that we are applying is P external, so it is P external multiplied by area. I hope यहाँ तक it is clear कि we are saying कि that force that is being applied on the piston is P external into area, and we have calculated the change in volume V final minus V initial, but keep that in mind कि यहाँ पर जो delta V होगा that will be negative. Okay, why it is negative? Because the final volume is less than the initial volume, so of course the value will be negative here. Okay. Okay, so this much we have done till now, that force will be equal to pressure into area, P external into area. Now we are calculating work done, right? So what is work done? Try to recall the formula of work done. आपने physics में पढ़ा होगा. So work done. So here we are talking about work done. It is equal to force into distance, right? What is the force into distance? So force is P external into area. Abhi we have calculated, and distance is L. And this A into L. What is this A into L, students? It is delta V, right? The change in volume. It is delta V, which is your change in volume. So I will be writing here as P external into minus delta V. Now you will be thinking कि ma'am why you have put minus here? Because here work done is on the system. Okay, and I have told you कि delta V की value negative आएगी. So negative, I have put one negative, and delta V की value negative आएगी. So negative will become positive, and you know work done on the system is positive. So to obtain positive value, we have put minus delta V here. Okay, of course there was lesser volume, like change in volume जो है वो decrease हो रहा था. So this is the formula for work done. Okay, minus P external into delta V. Now don't think this work done is positive negative कि मैम आपने तो बोला था work done on the system is positive, but यहाँ पर negative है. No, because delta V will be negative, right? And negative negative मिलके क्या बन जाएगा? Positive answer आ जाएगा. So work done on the system is positive. So I hope this much is clear to you people. Now students, one more thing here, you have seen that the pressure was constant. Okay, now let's say if the pressure is not constant, all right, and it is changing in a finite number of steps. Okay, कि थोड़ा थोड़ा करके in finite number of steps it is changing. So in that case the work done will be summation of P delta V. Ki means at every step we will calculate the work done and then we will add that up. Okay, P delta V calculate करके for every step, then we will add that up. But if the P is not constant again, but it is changing in such a way that there are infinite number of steps, ki means hamesha what will happen that your P external will always be greater, infinitesimally greater. Okay, infinitesimally means hamesha it will be greater than the pressure. Okay, means the continuous change is happening. We are not talking about different steps, means infinite number of steps happens ki every time P external is infinitesimally greater than P, and in that case the volume will be changing by dV, which is a infinitesimal small change. Okay, means infinitesimally small change in volume. Okay, in that case the work done will be the integration. You know, for continuous functions like this we do the integration Vi to Vf P dV. Okay, so in that case the this thing will happen, integration we will be doing. Okay, so such processes, now this process can be reversed at any step क्योंकि the process is taking place in infinitesimally small steps. Okay, थोड़ा 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 करके, like it is increasing and the volume is decreasing. This is the decrease in volume, so we can reverse it at any step, so we can call it as a reversible process. Now the two things are there, reversible and irreversible process. See the graph here. Okay, so this is the pressure and volume plot. This is important, so you must know that the pressure and volume plot looks like this. Okay, for compression we are talking about the compression of the gas right now. Okay, and if it is taking in finite number of steps कि देखो पहले ये finite, फिर second step, फिर third step, फिर fourth, फिर fifth, so we will take the summation of that average. Okay, so we have taken the average for that. Okay, but if it is like happening in infinite steps, मतलब reversible conditions में हो रहा है, so it will be a continuous curve. All right, so this process is said to be reversible if the change is brought out in such a way that the process could at any moment be reversed by an infinitesimal change. कि छोटा सा change करके we can like reverse that process, so at any moment, so that will be called as a reversible change. And it proceeds infinitely slowly by a series of equilibrium states. Okay, एक step में नहीं होगा, it will be happening in infinite steps. And other than reversible processes जो भी होंगे, we will be calling them as irreversible processes. Okay students, so this is the major difference. So please note the graph also, it can be asked in the exam, and you must know the work done formulas as well. Okay, so this was regarding the compression. Now let's say if I am talking about the expansion of the gas, so what will happen in that case? So students, if I talk about this expansion thing, before that I want to tell you one more thing. So if I am talking in this case, like where the pressure is increasing infinitesimally in small steps. So let's say the pressure is increasing in increasing by dP. So what I can say is for compression, the P external would be P internal plus dP, and for expansion, this is for compression. So for expansion, जब gas expand हो रही है तो P external जो है वो less होगा, then P internal means P internal minus dP. So what I can say that P external is equal to P internal plus minus dP means the small change in pressure that we are doing for reversible processes. So what happens in chemistry, we face some problems that can be solved if I relate the work done. So now this is the reversible work done that we are talking about. Okay, so I need to relate it to internal pressure of the system. So how can we can do that? So instead of external pressure, like this is the formula, right? Vi Vf minus P external dV. So instead of P external, I can write P internal plus minus dP dV. Now this will be the product. Now this is a small change in pressure, small change in volume. The value like small values unko multiply karenge, we will get further small value. So I can neglect that. So I'll be just left with P internal into dV. So the reversible work done will be, now we have related it to the internal pressure. Okay, now internal pressure of the gas, internally हमने क्या लिया था? Ideal gas ली थी, right? We were taking ideal gas. So now you can just write it as P also. So you know, for n mole of ideal gas, we will apply the ideal gas equation. PV is equal to nRT. So from here, P is equal to nRT upon V. Now you can put it here, okay, at constant temperature. Means now I am talking about isothermal process. So these are the different types of processes also that we are having. The ones that take place at constant temperature, okay, that will be known as isothermal process. So यहाँ पे हम integration करेंगे with respect to V. So 1 by V dV है ना, इसकी integration क्या होती है students? Log V, natural log V. So natural log V की when we will put the limits Vi to Vf. So see, integration हो रही है ना 1 upon V की. So log V Vi to Vf. So I'm just showing you about like how to do it. So log Vf minus log Vi. So log A minus log B is log A upon B. So यहाँ से expression आया. Okay, don't get confused कि where this expression has come from. All right. So see, it will come out to be minus nRT as it is, because these three are constant. We have taken the temperature also as constant. So minus nRT natural log Vf upon Vi. So अब natural log को हम change करेंगे. It will be coming out to be 2.303 log to the base 10. So यहाँ से reversible work done किसके equal आ गया? Minus 2.303 nRT log Vf upon Vi. Now this is an important expression with respect to your numericals. So if you know this expression, you can find like give the values, just put the values and solve any numerical. Okay, so this is the reversible work done that we have discussed for the particular case, that is where the gas was getting compressed. Okay. So students, if I talk about free expansion of the gas, free expansion means whenever the gas is expanding in vacuum, means the external pressure is zero. So we will be calling it as free expansion, and no work is done during free expansion of ideal gas, whether the process is reversible or irreversible, because in reversible and irreversible processes, in both the case, its work done is equal to P external into dV na. So that is the thing. Now if I talk about this work done, and if I put this expression in delta U, so delta U is Q plus W, right? And if I put W as minus P external delta V, this is irreversible work done, okay? And reversible work done, we have just calculated this one, okay? This is reversible. So now let's put the value. Now if the process is carried out at constant volume, okay, now if the processes are carried out at constant volume, we call it as isochoric process. Please note. So in that case, delta U will be equal to Q only. And if I put subscript V, means that here the heat is being supplied at constant volume. Okay. So if I talk about isothermal expansion of ideal gas into vacuum, and we are talking about free expansion, so W is 0, P external is 0, and Joule determined experimentally that Q will also be equal to 0. Okay, so it means there will be no change in the internal energy. Okay, so for reversible, तो it's like 0 ना. For isothermal expansion in vacuum, means free expansion की अगर हम बात करें, so delta U is 0. But if I talk about isothermal, irreversible and reversible changes, so for irreversible changes, Q is equal to minus W. Why? Because delta U is 0, right? Here we have seen कि delta U is 0. So Q will be equal to minus W. So Q will be P external V final minus V initial, क्योंकि minus minus will cancel. And for reversible change, again Q is equal to minus W, so it will be nRT log Vf upon Vi. Okay. And for adiabatic change, Q is 0, so delta U is equal to work done. Okay, that adiabatic work done that we have earlier also discussed. Okay, students. So that's what we have considered here for the free expansion. So students, we have discussed the basic concepts of thermodynamics in this lecture. Okay, we studied the very basic terms that are used in thermodynamics that will be helpful for you. Okay, and then we studied the first law of thermodynamics and its applications. Now in the next lecture, I'll be talking about the enthalpy. Okay, enthalpy is again a very important thermodynamic property that we will be discussing. So various things related to enthalpy, and we will try to cover second law of thermodynamics in that also. Okay, so before I end up, I just want you to solve this particular question. Okay, so the question says, in a process 701 joule of heat is absorbed by a system and 394 joule of work is done by the system. Okay, so heat is absorbed by the system and work is done by the system. So you need to find out the change in internal energy. So change in internal energy is Q plus W. Okay, but keep that in mind, the sign conventions. Okay, I am not going to tell you because we have already discussed. So keep in mind the sign conventions, whether you have to take the heat as positive or negative, or whether you have to take the work done as positive or negative. So according to that your answer will come. This is a very simple NCERT based question, but it's a basic question. So when we solve basic question, our basic concepts get cleared and we become ready to solve higher questions. Because I feel like some of you tell me ki ma'am, there are a lot of problems in solving chemistry numericals. So try to practice as much as you can and try to practice from the basics. So I want answer for this question. Now how are you going to give the answer? Try to give the answer in the comment box. Okay, comment section may just post the value of delta U, ki so and so joules it is coming out. Okay, so post this in the comment section, and in the next lecture I'll tell you what is the answer for this question. But I want maximum comments. Okay, I want maximum comments from you people, because then only we can solve higher order numericals. Okay, if we are able to solve the basic ones, because here we have discussed first law of thermodynamics, so I have given you the very simple question from that. Okay, and I expect the answers from all of you. So now we will be meeting in the next lecture where I'll be talking about, I have told you, that enthalpy and second law of thermodynamics. So see you then students. Until then, take care. Keep learning.